Hello there, welcome back to the LLVM tutorial walkthrough where we have been walking through the LLVM, my first language front end with LLVM tutorial. We have made it past the first 5 chapters, and so right now we're gonna try to go after chapter 6. So let's do it. Okay, so chapter 6 is about this idea of user-defined operators, as in you can custom define what the plus means, I believe, and maybe even other operators, like you can define the @ symbol to be a custom operator. You can have unary operators or binary operators. So these guys are binary operators because a binary operator takes 2 operands. A plus operator has a left-hand side and a right-hand side, and there's 2 operands. So these guys are binary. Unary operators have 1 operand. So the exclamation point, like you do something like if it not completed, so that guy is an unary operator. Okay, so the scheme that we're gonna take following chapter 6 is that we're going to be able to custom define either unary operators or binary operators. And you would write a unary operator like this, where you first write either the word unary or binary to name the type, and then you write the symbol of the operator, in this case the exclamation point, and here there's the greater than. And then you write some code which is going to execute when that operator is used. So that's the idea. We're going for this syntax. We have this def. I believe we had a def for defining functions. Is that true? Yes, we already have the def tokens. We already have the def token for defining functions in the style of Python, but now we're going to use def to define custom operators as well. That's the idea. So let's write the tokenizer for it. So operators, what are we going to do? So we're going to have, we're going to add 2 tokens. These keyword, the unary and binary are keyword tokens, so we're gonna add those into our tokenizer. So that makes sense. Okay, and then we're gonna add these 2 clauses to this if statement down below, where whenever we parse an identifier, we exclude the keywords from being an identifier. So this is grabbing alphanumeric identifiers, and after it grabs an identifier, we have to check whether the name is one of our keywords, and if it is one of our keywords, we can't allow that to be an identifier. So this is the exclusion logic here. So I'm just gonna copy this in. I'm gonna put in the blocks. Okay. So that will give us the binary and unary keywords as seen here and here. And then what is this thing doing here? We're gonna need to update the prototype AST node. Let me just remind you what the prototype AST node is. It's the prototype of a function. So previously, to define a function, you would write something like this. The def my fun, I believe, and then you have a parenthesis list, and then or a parameter list, I should say. So this guy is the prototype of a function. So when we're dealing with when we're saying prototype AST, it's the AST node that represents this part of the statement, not including the body of the statement. So now we're gonna basically say, well, it's more complicated than that because we can have these custom operators in this prototype syntax. We can have this unary thing and this binary thing and this symbol, and there's even this number here. When in the case of the binary operator, there's this number which gives the precedence of that operator, or allows a user to define the precedence of the operator, and we currently have handling for precedence of operators, and they're defined as such. Multiply and divide have higher precedence than plus and minus, and then which in turn has higher precedence than less than and greater than. I actually believe the tutorial has only defined one of less than and greater than. I think it defined greater than, I believe, but whatever. I think it's probably left one of them out so that it can be implemented as a custom operator, is what I'm guessing. But anyway, so let's add this new code to this prototype AST. This is the code for parsing it, but I think we're gonna change the class, I believe. Where is the class? There it is. Okay. So it used to be like this, and we're gonna actually add a whole bunch of stuff to it, including a boolean, a flag that says it is an operator or not, unsigned precedence. In the case that it is a binary operator, it's gonna have a precedence, which is an unsigned number. And then we're gonna need to add those things to the constructor. So let's do that. So there's a bool is operator and an unsigned precedence. And then this is the initializer list. So I'm gonna write this in initializer list syntax. Okay. And then looks like we're gonna make a couple of methods to tell you whether it's an unary or a binary operator. That's fine. We can do that. I have not seen this const syntax before. I don't know if that means it's a constant method or what. This looks really weird. If you know about this syntax, please enlighten me. I don't know what this const is doing here. Okay, so if the args.size is 2, then it's a binary operator. Otherwise, if its arc size is 1, it's a unary operator. And then we're gonna have a get operator name method, which is also const. Maybe it means I think it means this doesn't mutate the variables in the class. That's probably what this const means. Like by calling is unary op, you're not modifying anything at all. You're just reading. Okay, so if they're just gonna error out if somebody tried to make an operator that has 3 arguments. Okay. This name is referring to this name. This name. Okay. That's just getting the last character of the operator, of the name, the last character, and it assumes that an operator has 1 character, I believe. That's suspicious. Like, what if we wanted operators that have more than 1 character in it? I wonder what we would have to change to get that working. That might be a bonus extra credit thing that we might attempt later. Okay. So this is just return. So we basically have these assessor methods to ask whether what kind of operator is it, all the information about the operator that would need, and then we're gonna need to parse it. So let's go to parse prototype, and we're gonna update this. This is gonna get a lot more messy now. This parse prototype function will get quite messy. So this eats a token. Wait. I think it's already eaten the def token at this point. So I mean, it looks something like def my fun xy, right? It looks something like this, or it could look like binary exclamation point 5 xy. Let's do star. Let's do @ sign. Okay, or it could be unary, which unary operators do not have the 5, so maybe the # this time, and this has to have 1. But I think the part that this method parses excludes the def token, because I don't see the word def referenced here. Yes, I was right about that, because the preceding line to calling parse prototype already ate the def token. Okay, so I'm gonna get rid of the def here. So these are the examples of what this method is going to parse. And we need some conditionals, because it could either be that or that or that, right? So, okay. All right, let's go through this. So, I have a kind function which is 0. We're gonna figure out the kind based on what type of thing it is. Okay, that's fine. And then it's gonna set the kind, if depending on the token type, we're gonna set the kind of thing we have, and then later on we might need to ask it what kind it is. I think that's fine. Okay, I'm going to follow suit. There's a function name. There's this function name here. Oh, there it is. Okay. All right. Let's do it like this. Unsigned kind is 0, and I'll just copy this comment for documentation's sake. And then the binary precedence, in the case that it's a binary operator, we're gonna have a precedence number. We're defaulting it at 30, and then we're not gonna eat the token just yet, I don't believe. We're gonna switch on the cursor token to see what type it is. I usually prefer to have the default statement at the end. So, although I'm just gonna do it my way. So if the token is an identifier, we know it's not a binary, or we know it's not the unary or binary keyword, because if it were unary or binary, we have special token types for that. And then we're gonna advance the token and break out of this switch statement. If it's a binary token, we're gonna advance the token in okay, we're expecting an is ASCII. Okay, is ASCII. I think that means it's a valid character. Oh, because negative numbers are not ASCII. So this is sort of like testing for the case where it's negative, because it might be negative if it might be negative if it were any of these tokens, because we made them negative. That was a little trick that the author of the tutorial is using. If it's negative, means it's one of our custom tokens types. But if it's non-negative or is ASCII, then it actually represents a actual character. Okay. And then the function name is going to be binary. Oh, and then plus that character, whatever that is. Okay, and then we're going to read the precedence number if it's present. So this advanced the token. So we were looking at this token here. Well, here we were looking at this token, and then did I write get next binary? This should be get next token. And then we advanced this token, and then now we're looking at this operator token, and then now we advance the token again, and now we're looking at this number token. which we're gonna use that to represent the precedence of the binary operator. Okay, so if the precedence number is not within the valid range, we're gonna error out. Otherwise, binary precedence is unsigned. We're gonna cast the num_val to unsigned. The num_val, I guess, is put there by the lexer. Actually, this is a global variable. Okay, and then we're gonna advance the token and then break out of here. Let me think. What about the unary type? And then there's a default case. Don't forget about that. Return null pointer. I prefer returning this null pointer explicitly. Why did it not test for the unary type? That might be a mistake. I don't see any reference to the unary operator type. Okay. If that's the mistake, then I could check at the end of the code listing at the end of this page. I'm gonna search for parse prototype. Yeah. They're supposed to have this toke unary clause here. They had this in the full code listing, but not in the middle of the article. Whoops. Okay, I'm gonna go ahead and copy that. Excuse me. Okay, this similar thing to the binary operator, except that we didn't have to deal with this precedence thing. Okay, so after that, what we're going to do is, let's see, we're gonna eat the identifier. I don't think we're gonna do that here anymore because we did it inside this switch statement. And then, okay, we're here. I'm matching this place in the progression of things. And then this is gonna read in the argument names. I don't think that part changes at all. But finally we have this, if the kind, make sure there's a right number of names for the operator. So I think this is saying if kind, which that means if kind is not 0, I'm gonna be more explicit and write if kind is not 0, which means if it's 0, it's an identifier. It's a normal function. But if it's 1 or 2, then it's an operator. argnames.size is not equal to kind. Okay, that's clever. The number, the kind number happens to equal to the number of arguments of that the operator would take. So if they're not equal, then we're going to error out. Okay, then I think we have to pass in the things, including the whether it is a operator or not. They just wrote, kind is not 0, that's a Boolean, and the binary precedence, if that exists. Okay, now we're gonna plug this in. Wait. Oh, okay, we're gonna go back here and follow the main flow of the tutorial now. Whoa, we have a Mandelbrot set going on. That's amazing. Okay, can't wait until we get to that point. Okay, so we just did this, but we followed the code in the main index. Now we're gonna write the code generator. Maybe we break it up actually, because that's what I've been doing in this series. So I'm gonna stop this video here, and then the next one we'll implement the code generation. See you there.